to continuing, ladies, factoring, okay, but before we do that, remember I told you guys yesterday we're gonna add, Crystal, Izzy, just wait 2 seconds, okay, we're gonna add an extra piece to what we started yesterday. So before I can do that, we need to go through some definitions that hopefully are review, and then we're going to graduate adding these terms, okay, to factoring, right? So does anybody know what LCM stands for? Anybody? Yep, go ahead. Right, so lowest common factor is another way, but what would be the M1? Lowest common, which means the same thing, okay? So lowest common multiple, okay? So we have LCM, right, which is lowest common multiple, and we have GCF, which stands for greatest common factor, okay? So when I ask you, okay, for the lowest common multiple of 5 and 12, okay, does anybody know what to do? What do you mean? Expand on that. I think you have them backwards. Yeah. So GCF will be that. So guys, lowest common multiple, right? If you had fractions, guys, I feel like I'm talking over you. Okay? If you had two fractions and I asked you to add them together, what would you have to do? You'd have to get the common denominator. Okay, do you guys agree? That common denominator should be the lowest common multiple, right? So if I had, say, a 1/2, we're going to do nice and easy. If I said I had a 1/2 and I was going to add a 1/3, what number would you guys get on the bottom? A 6. That's the lowest common multiple or lowest common factor, okay? So that is what this would be. So to figure out the lowest common multiple for 5 and 12, it's not as easy to do in our head. Do you guys agree? Because you can't visualize that one probably. But what you would have to do is picture it like this. What are my multiples of 5? 5, 10, 15, 20. Do you guys see where I'm going with this? Right? And we could go on forever. Okay. Right? 50. And again, you don't need to write this down. I just want to show you guys something really quick. Okay. And then 55, 60, 60. I'm just filling up one line and then I'm going to stop. Right? Do you guys agree, dot, dot, dot? Oopsie. Again, don't write this down. I just want you guys to see this. Okay? Do you agree that those are multiples of 5? Okay? So then my multiples of 12 would be 12, 24, 36, 48, 60, 72, but again, can I stop? Dot, dot, dot. As soon as they're the same, that is what's common, okay? So the lowest common multiple would be 60, right? So think of LCM as, what would that number be on the bottom if I made fractions of over 5 and over 12, okay? You would have to make the bottoms both be 60, right, to make the tops go together, okay? So that is what's lowest common multiple is, okay? So the first multiple that they both divide into, right? So it gets higher and higher. Does that clear that up with lowest common multiple? Okay. Right, and then, yeah? Yeah. Right, because multiples, you have to do the multiples until they get the same. And the thing is, could you be there forever on some numbers? Like if I said, what's the lowest common multiple of 108 and 560, right? If there is a multiple that's the same, that's what you would have to do. We aren't going to be focusing on this. I'm just going through the definitions, okay, of the difference, because we're going to be focusing on GCF, okay, right? But sometimes students get these backwards, so I want to make sure we understand lowest common multiple versus greatest common factor. So greatest common factor, right, is the highest value, so the greatest value that can divide into the expression or the polynomial, depending on what we're looking at. Okay? So if I had 16 and 24, what's the greatest common factor with 16 and 24? Right, 8. Okay? Because does it have other factors that they share? Yeah, they have other factors that they share. They share a 2 factor. They share a 4 factor, right? They share an 8 factor. So greatest common factor is the number that can divide out evenly, okay, from both. So you can layman's terms both, however you want, right? These are your notes. I typed it really quick before, and I'm just going to drag it over, right? So we talked about it, right? You make your own written part of what they are. So for the purpose of us being able to continue to factor, okay, we do need to take out greatest common factors, right? Because it is another product, and we know that when we're factoring polynomials, do you guys agree yesterday we spent 60 minutes figuring out 2 binomials that multiplied to get to the polynomial? Do you guys agree that that's what we did yesterday? Did we get pretty good at it? Okay. Every single question I gave you guys last class did not have a greatest common factor in the polynomials. Okay? So we are going to be looking for those today. If there are that, like if there is a GCF, we have to take it out. Okay? Sometimes there isn't going to be one. But I know that that sounds confusing right now, so bear with me. Okay? All right, so we're just going to baby step our way into this. So state the GCF for each pair of terms, okay? So you guys are used to GCFs with numbers. Right? I'm going to graduate to you so that you're also okay with taking GCFs from polynomials, right? Whether it be a monomial, trinomial, binomial. So with this, let's start easy. So 36 and 27. If you know your multiplication tables really well, can you just tell me what the answer is? Right. You know it's 9 because you know your multiplication tables really well. If you don't know 9, okay, do you have a way that you can figure out that it's 9? Yeah, like you would break it down into its factors. So I'm going to show you this just for those ones that don't see that that's 9. Okay, so if you broke it into its factor, let's do one each one individually. So you do have to figure out what 2 numbers can multiply to give me 36. 6 and 6. Okay, and then 6 and 6 breaks up into 3 times 2 and 3 times 2. You guys did a ton of factor trees, right, in junior high. And then 27, right, you would have to be able to break it down, so whether you use your calculator or not, you would try a 2, it wouldn't work, right? Then you would try a 3, and then 3 times 9. So then 3 can't break down anymore, but 9 can. 9 times, right, 3 and 3. So then you would look at your factor tree, and what do they have in common? All they have in common is 2 3s, right? So that is why your GCF is a 9. All the questions, guys, in our 10C work, if you know your multiplication tables, you will not have to do that. They're all going to be numbers within like our 12 times tables. Okay? But if you can't look at it and see what the GCF, if you break it down into its factors, prime factors, whatever they have in common is your greatest common factor. Okay? Do you guys remember doing that? Right? So again, this you'll probably be able to skip. Right? You won't need to show that work, like I said, unless, right, you struggle because 36 and 27, if you didn't know that 9 went into both of them, then you break it down. Okay? Same thing, guys, with variables. Okay, so I have 2 terms. I have an a squared and a b6. and I have an a cubed and a b. Anybody want to guess or tell me what they think the GCF is?
AB.
So, yes, but I want more A's. Because what do they have in common? Think of if I expanded both of these. How many A's are in both? 2. Don't both of them have an A squared? Right? How many B's are in both? 1. So this one would have a GCF of A squared B. So again, if you're confused, watch. Do you guys not agree that this is the same thing as A times A? This is horrible to do this, but you guys need to visualize this. Do you guys agree that that would be if I broke it all into the prime factorizations? Yes, yes? So then this other one, so this is A times A times A times B. What do they have in common? They have 2 A's and 1 B. Right, so you have to think, what can I divide out of both of them evenly? Right, so basically the lowest degree of the variable will be at, right? So this one has an A squared, this has an A cubed. The most I can take out of both of them is A squared. Right, this one has 6 B's, this one has 1 B. So the most I can take out of both is 1. Okay, so that would be your GCF of these two terms. So your GCF would be an A squared B. So here I put both. So now we have to look at numbers and variables. So with the 8 and 36, what number can divide, the largest number that can divide into 8 and 36? So all I do, guys, for these ones is you look at the smaller one and go through all its factors. Okay? Because with 8, I would start at the high end. So 8 can go into itself. Do you guys agree? Can 8 go into 36? We should definitely have a clear consensus of yes or no. Which one? No, it cannot go into 36. But if you aren't sure, what do? Grab your calculator and go 36, divided by 8, and you'll see that it's a decimal, so it doesn't work. So the next biggest factor of 8 is 4. So then try. Does 4 go into 36? Yeah, so that's how you know it's your GCF. So take the smaller number and use its factors. Because if they're bigger, you don't use the bigger number, right? Because the bigger number is going to have larger factors than even what 8 is, okay? So that's why just use your smaller. And if there's 3 of them, you use the smallest, okay? And use all its factors. The one that works, okay, going from high to low, will be your GCF. That's why I did not start with 2. Right? 2, do you guys agree that 2 is going to work a lot? Yeah, but it's not going to be the biggest one. So start on the high factors and work your way down. So again, do you guys agree that 4 divides into both of them? That's the highest one. So then I have 4. Now look at the x's. This one has x10. This one has x3. What's the most I can divide out of both of them without getting into negative exponents? Right? So x. I can take 3 out. Because doesn't if I take 3 out of that, that gives me x0? X to the exponent of 0. It's always the lowest degree. Because again, guys, picture this. I'm not going to keep writing it down. Is this not x times x times x? This is x times x times x 10 times. How many do they have in common? 3. So it's x cubed. Okay. Now picture I have 1x there, or sorry, 1y there, and 3 y's here. What do they have in common? 1. So it's 1y. That would be your GCF using those two terms. Okay. So before we do more, okay, let's do whatever, 24. You don't need to write this down. I just want to make sure we're good because some of you I feel still are a little bit, gentlemen, if you have a question, ask me. All right. All right, so with this one, We have 24 and 12. So what's the smaller number right now out of those two? 12. So now we look at the factors of 12. So I start with 12. Can 12 go into 24? So that's your GCF. So I don't need to go break it down further. So 12 is the GCF for the numbers. Now I have 5 x's in the first, 5 x's in the first one, 7 x's in the second one. What's my GCF for both terms? 5, exactly. I have 6 y's in the first one. I have 5 y's in the second one. The most I can divide out is 5. So that would be my GCF. Okay, looking at those two terms. Is that starting to make sense? Okay. All right. So how we're going to add this to factoring is when you take a greatest common factor out. So let's actually go back to something you guys are used to seeing. Okay, I'm going to try to make a connection like I did yesterday, which really worked well with you guys. So if I gave you 2x plus 1 and I put outside here a 3x, do you guys all agree that you could expand that? Right? So this, I would expand it by multiplying the 3x in, right? And I would get a 6x squared plus 3x. So now, guess what? I might give you some polynomials, okay, that all you can do, because do you guys agree that 3x is a GCF? Yeah. That, what you're going to have to do is look at the polynomial. If you just have a degree 2 term and a linear term, which means a degree 1 term, all you can do to factor this is take a GCF out. That's all you can do. It doesn't get 2 brackets because there's no constant term. Because remember, factoring means you're breaking it up into its, what word do I want to hear? So what we did yesterday, we took a polynomial, we broke it up into its factors, which means what operations happening with factors? What's operations happening here, guys? Multiplication. So we're breaking it up into its products. So another word for multiplication is products. That's what factoring means, is break it down into its products. Okay? So what we didn't do yesterday is I didn't want to do GCF first. I didn't want to overload you with too much to think about. But now, GCF is something else you look for when you're factoring. Because do you guys agree that this is not a degree 2? Right, it doesn't get 2 brackets ever. Right, only degree 2s get 2 brackets, potentially. Okay, so could this still be broken up into products? It can, because you look at each term, you have a 9k, so picture what we just did, guys, don't write this down, but if I said 9k and 6, just individual terms, does that have a GCF? So that's what you're doing. You're breaking it into its products. So if you have a 9k and a 6, 9 and 6, 6 is the smaller number, so can 6 go into 9? No. What's the next factor of 6? 3. Can 3 go into 9? Yes. So then you know your GCF is 3, so it goes on the outside. And then you look, can I take any variables out? No, because the first one has a k, but does the second one have any k's? No, so that is your GCF. So then bracket, what do you have left? Right, so picture, guys, all we're doing is working backwards. Okay. So remember, to go into the brackets, we multiply. Do you guys agree? So to come out of the brackets, we divide. So this is what you're picturing. To take your GCF out, you just divide every single term by the GCF, and that's what's left in your brackets. Right? So 9k divided by 3 is 3k plus, because the sign didn't change, we took out a positive. 6 divided by 3 is 2. And just like yesterday, right, I just broke it into products. Okay, that is still factored. There are 2 products there. Can you multiply it back in to make sure that you did it correctly? Yeah, that's the nice thing about factoring, right? You can always multiply your factors out to make sure it gives you what you started with. Okay. Right. So this little guy here, okay, definitely not a degree 2. It doesn't get 2 brackets. So you're always asking yourself now, guys, is you look at all the terms and ask yourself if there's a GCF. That's now your first step from this day forward. You didn't have to worry about that yesterday, but today now you do always. So with this one, again, you're just picturing, I have an 8y cubed and a minus 12. Okay, so don't really worry about the negative, right? But look at the 8 and 12 first. So 8's the smaller one. Can 8 go into 12? No. So the next factor of 8 is 4. Can 4 go into 12? Yes. So I need a 4. So 4 is definitely coming out. And then now look at the variables. I have y cubed and a y. So the most I can take out is a y, right? Because again, you have y, 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 y. What do they have in common? Only 1. So that is my GCF. Right, so then, this is the piece that sometimes is a little bit weird for students, right? To tell what you have left in the brackets, remember, because we took that out. To put in, we multiply. To take out, we divide. So 8y cubed divided by 4y is, well, good, 2y squared. Minus 12 divided by 4 is 3. And the y's divide out, right? So they're gone. Now, is that a degree 2 polynomial? It is, but it's not a difference of squares, right? So that's not factorable. That's as far as you can go. Do you guys remember what difference of squares means from yesterday? For this to, if this ended up being, guys, when I was done, a 9y squared minus 25, you would have to go further because that would be factorable. But this is impossible, can't be factored any further, so you're done. Right, so some will just have GCF, some will have both. Some will have a GCF and what we did yesterday. Okay? They're all factoring. All right, so is this starting to look a little similar to what we did yesterday? Is that the form we did yesterday? Yes. So this is what I'm talking about. Still look at each term individually. So there's 3 terms now I'm looking at. I have a 3y squared, a 2y, and a 24. I don't really care about signs. I just want to see if there's a GCF. So do you guys agree I definitely can't take a y out because there's not a y in all 3 terms? But I have a 2, a 2, and a 24. Is there a factor that can come out of all 3 numbers? What number? So you need to take that out first. Okay. Yesterday you didn't have any that was like that. So it's just an extra step. Right? So we take out the 2. So remember, all you're doing is dividing out a 2 from each term. Right? So it goes outside because you're taking it out of the brackets. So then we're left with y squared minus y minus 12. That is not done. So now you go to what, as long as it's in that form, ax squared plus bx plus c. Remember all those ones we did yesterday? Was it that form? You are not going to factor further anything higher than a degree 2. This you can factor further. So the GCF stays out. Let's see how much you guys remember from yesterday. What's going to go at the beginning of my brackets? Y, right? 2 things that'll multiply to give me y squared are y and y. 2 things that'll multiply to give me 12 are, right, 4 and 3. I'm not using 6 and 2. You guys are already starting to look ahead a tiny bit because I need a 1 in the middle, right? So if we use 4 and 3, right, the inside gives me a 4y. The outside gives me a 3y. I need a minus 1y. So the 4 needs to be, I need a negative 1, good, and then the 3 will be positive. Because I know I need more negatives than positives, right? So if I need more negatives than positives, the larger number is always going to be the negative, right? So I check the inside first, so that goes, the negative goes into the first bracket, and the positive goes into the second bracket. So one extra step. And do you think you're going to have a GCF in every single question you do? No. I would say you're going to have a GCF 1 in every 10 you do. But do you think students forget because it doesn't show up very often. They forget to look for it. Yeah, so just make sure that's your first checklist. Look at all your terms. Don't. Do a little checklist. No GCF. Then move on to what we did yesterday. Pretty much majority of the questions. Okay, but they will show up. All right, so this little guy here. All right, so we have, look at each one individually. So look at the numbers first. So I have a 3, a 6, and a 12. So the smallest number is a 3. So check. Can 3 go into 6 and 12? There's your GCF. Right, for a number. Now look at all your A's. I have 2, 1, and 1. So the most I can take out of all 3 terms is a 1. Now look at the B's. I have 1, 2, and 1. So the most I can take out is 1. That is your GCF. And then, so you guys can see, not that you have to write it underneath here. It's just I find if I don't write it underneath at the beginning, students don't visualize the answers inside the brackets as much. As soon as I do that, can you guys actually see your exponent laws up here? Right? That's all you're doing is using your exponent laws to break these down. So 3a squared b, and the nice thing is it's all grade 9 exponent laws. Because if you're taking out the proper GCF, you shouldn't be getting any negatives, right? Negative exponents. All right, so 3 divided by 3 is 1. A squared divided by a is a, so that's left inside. And then b divided by b is gone, right? Because it divides out to a 1. Minus 6 divided by 3 is 2. Any a's left? No. Any b's left? 1. Plus 12 divided by 3 is 4. Any a's left? Any b's left? No. So you're done. And then as soon as you take a GCF out, you just look inside the brackets. The polynomial that I have left, is it in the form of ax squared plus bx plus c? Is it or not? No, so you're done. Does that make sense, guys? I see like there's some confusion. Does it make sense when I say ax squared plus bx plus c, what that means? All the factoring we did yesterday, guys, these two would be in that form. See how there's a degree 2 term, a degree 1 term, and a constant. That's what you're looking for. If there's that form, then you need to try factoring further, okay? If it isn't a degree 2, a degree 1, and a constant, or that difference of squares, right? That's the only other case that would be a little bit different, right? You're done. You're finished. All you can do is a GCF. Okay. All right. So that's finished. Is this one identical to yesterday? Yeah, so this one, look at each term. You have a 6, 7, and 3. 3 is the smallest. Does 3 go into 6 or 7? No. Does the only other factor is a 1, so 1's not going to change anything. So there's no numbered GCF. Can I take any x's out? All right, because it has to come out of each term. So is there an x in each term? No, so there's no x term there's no GCF. So this is in the form of degree 2, linear, constant. So we have to factor it, right? Because there's 2 products that are going to work. So now we're just doing what we did yesterday. So what are the 2 numbers you guys want to use for 6x squared? You pick. Perfect. So 3x and 2x. Doesn't matter which one goes where. But now this is what I was talking about last class, guys. Do you guys agree that 3 and 1 are the only 2 numbers that can multiply to give me 3? This, don't ever do. Because did I just create a GCF in that bracket? Did we already say that there was no GCF? So that just allows you to take out that option. Because you said there was no GCF, so you can't put a GCF into a product bracket. Just save some choices, right? If you forget that, can you still get the factoring right? Anybody? If you did this, right, can you still get the factoring right if you're checking your work? Yeah, because if you did that, check. 6 in the middle, right? 3 outside. It doesn't work, right? That's what you would do. You just do an extra step. You'd find it, oh, that doesn't work. It doesn't give me the 7, so then you would erase it. It just saves you an erasing step, guys. That's all I'm saying. Once you get good at this, that's a little, not trick, it's just, we said there was no GCF, so you can't create a GCF, right? So then you know that the 1 has to go in the first bracket, and the 3 has to go into the second bracket. So see how the inside gives me a 2x, the outside gives me a 9x. And do those two numbers work perfectly for the 7? Yes. So I need a plus 7. So the 9, I need more positives than negatives. So the positive will be the, I need more positives than negatives. So the 9 will be positive and the 2 will be negative. Because again, 9 minus 2 is positive 7. Checked. So the minus goes into the first bracket and the positive goes into the second bracket. So remember, guys, use your calculator if you're still yucky with integers. Right? If you go minus 2 plus 9, that gives you a plus 7. If you go plus 2 minus 9, that's going to give you a minus 7. The signs aren't going to line up. And that's done. Right? Nothing else we can do. It's broke down into its product. Right? And just think, guys, you're breaking it down into the prime factorizations, but it's polynomials. Right? It's a little bit more abstract, but that's technically what you're doing. Right? You're doing a factor tree on this. Right? Can you guys visualize that? Right? It is technically a factor tree. And you can't go any further, okay? And if you would have, well, actually, maybe I'll have one that I can show you guys, right? So if there is a GCF in one of those brackets, actually, I'm going to, don't write this down. 2x plus 4x minus 3. And this was a 2x. I just want to show you guys something, because this, again, is the biggest mistake students do. Not mistake, but not finishing it. So 2x squared, so that's minus 6 plus 4, so minus 2, x minus 12. All right, so would you guys agree that these two products that I just wrote are the products of what I wrote at the top of that polynomial? Do you guys agree that this could be the two branches? Do the quick expansion. Do you guys agree that they are? But this would not get you full marks. Because can one of those brackets still be broken down further? Yes. So this is not finished. Okay? This one can't be broken down any further. Right? Not that I want you to make trees like this, guys, but I'm just trying to use something that you guys have done in junior high to make the connection. This branch or this factor here can be broken down into two more factors. Because what can come out of that bracket? What's the GCF of 2x plus 4? 2. So this has to be broken down further. That is now completely factored. Okay? Because a lot of times students will factor this one right here exactly like that because they'll forget about the GCF, which is fine. Okay? But you better catch it here. Okay? So when you're done, always look at your brackets to make sure that none of them can break down further. They have to be, kind of picture it like all the primes. Right? None of those can be broken down any further. X minus 3 can't be broken down any further. X plus 2 can't be broken down any further. Okay, your GCF is the largest number that can come out, which in this situation is a 2. All right, so with this little guy here, so each term, right, I have a 3, a 5, and a 4. So is there any GCF for numbers? No. Right? Because the smallest numbers are 3, right? And the factors of 3 are 3 and 1. So 3 cannot go into 5, it cannot go into 4, so there's no GCF for numbers. But do I have a GCF for a variable? Yes, because I have an a cubed, an a squared, and an a. So I can GCF out a. So I can take out an a, because that's common. So then I'm left with 3a squared plus 5a minus 4. Am I moving on to the next question? I heard yes and no. Am I moving on? No, good. Right, because is that a degree 2, a linear and a constant? Yes. This was a degree 3, a linear and a constant, you'd move on. You don't factor higher than a degree 2. You would leave it. That's all you'd be able to do. But here it's in that perfect form that can get 2 factors out of it. Right, so then we leave our GCF out because it is a factor, right? Think of that's one of your, if you're picturing your primes, right? It's one of those factors, but I can get 2 more out of a degree 2 polynomial. So how do you want to break up 3a squared? Exactly. So the only way we can. That one has no choice. So 3a and a. And again, did anybody write an a and a 3a? Is that okay if you did? Yeah, it doesn't matter, right? You just break it up, right? Because it is products, order doesn't matter. But the next number does, right? When you have a coefficient of something other than 1 on the degree 2 term, the second number, you have to make sure that 5a comes out in the wash, okay? So how do you guys want to break up the 4? Do you want to use 4 and 1 or 2 and 2? You pick because I don't care. 4 and 1. So if we use, so let's visualize. So if we use 4 and 1, if I put the 4 here, I created a what? If I put it in the second bracket, I create a 12. Am I way too big? If I put a 4 here in the inside, I create a 4, but then what is created on the outside? A 3. So 4 and a 3 is a 7. So should I use 4 and 1? No. So hopefully you guys are sort of doing that now without writing it down. So let's try our 2 and 2. So if I put a 2 in on the outsides, I get a, picture it, a 6. Okay. If I put a 2 on the inside, I get a 2. Right? So 6 and 2, so maybe this isn't factorable, because that'll be 12, that'll be 4, that'll be 3, 2, 6, 5, 4. So is this one factorable? Can we go further? No, because are those the only things that I could have tried? Yeah. I promise you on a quiz or a test, guys, I'm not going to give you one that doesn't work. I'm sorry that I put one on here. So that's as far as you can go, because 4 and 1 didn't work in either bracket. 2 and 2 didn't work. And those are the only choices I could have tried. So then we're done because nothing works. And like I said, I promise you on a quiz or a test, if it's that form, I'm not going to make you try everything like we just did. Something will work. And I'll fix that for next time because that's just mean. All right, so then that, but guys, did we still factor it? Did we still do the heading of factoring? Yeah, it's still in 2 products. It's just we couldn't break it down even further. All right, so this one's looking bigger and scarier, but same process. So we have a 6, a 10, a 14. So the smallest number is a 6. Can 6 go divide into 10 and 14? No. All right, so 6 cannot go into 10 and it cannot go into 14, right? 14 divided by 6 doesn't work. 10 divided by 6 doesn't work. So what's the next highest factor for 6? Next highest factor for 6 is 3. Can 3 go into 14 and 10? No. So the next factor of 6 is, does that one work? And that's the thing, guys. Did you guys know it was 2 automatically as soon as you looked at that? Yes, but again, I'm just doing process. So because if the numbers aren't as easy to look at and you know right away, you have a process, right? Because sometimes students don't take the largest number out. So what I'm doing with you guys will always guarantee that you're going to get the largest. Right, so I definitely can take out a 2. Now I have an m squared, m, and m. What's the most m's I can take out? 1. I have an n squared, n cubed, n6. The most n's I can take out is 2. Good, n squared. Perfect. So that is my GCF. So that is what's coming out of each term to tell me what's left inside the brackets. All right, so 6 divided by 2 is 3. How many m's do I have left? 1. How many n's? Nothing. Good. 10 divided by 2 is 5. How many m's? 0. And how many n's? 1. Good. Plus 14 divided by 2 is 7. How many m's? None. And how many n's? 4. Perfect. So then you look inside. That is not a degree 2, a linear, and a constant. It's a degree 4. You're not factoring any degree 4s this year, so you're done. Right? And then you have m's and n's left, right? That is not in a pattern that you know how to factor further, and it's actually not factorable, okay, further. So you're finished. Right. Almost done, and then I'll let you guys play. Right, oopsie. Last one. All right. So this one, GCF for number is what? 2, right? Because 2 is the smallest number. 2 can go into 20 and 48, so I can definitely take out a 2. Sorry. 2. How many B's can I take out? 1. Right, so I can take out 1 B. So then I'm left with bracket. All right, so 2 divided by 2 is 1. B cubed divided by B is B squared. And then 20, so the sign stays because we're not changing. We didn't take out a negative or anything. So minus 20 divided by 2 is minus 10, and I still have B. Plus 48 divided by 2 is 24, and B's are gone. So this one, can you guys already see this one's going to be factorable? Yeah, so this one I'm not leaving you hanging out to dry with trying a million things. This one will be factorable, right? Just because it has a leading coefficient of 1, and I'm hoping you guys have done enough that when it's a leading a coefficient of 1, you can see right away that if it's going to be factorable or not, right? As long as you know your multiplication tables. So 2 things that multiply to give me B squared are B and B. So this one, we have to be a little bit careful. What are the 2 things that will multiply to give me 24 that we're going to use? So 4 and 6. So if we use 4 and 6, 4 is going to, the inside's going to give me a 4B. The outside is going to give me a 6B. For me to get a negative 10, do you guys agree that we have to add them together? But I need a negative, so they'll both be negative. Does that work for the 24 on the end? Yes. Was anybody thinking 12 and 2? Not one of you? That's a common mistake students do for this one. Okay? This is what I've seen in the past. You tell me why it's wrong. Oops, let's use a different color. Because I guarantee you guys there's only one answer that's ever correct. Okay, there's never more than one answer. But I see this sometimes. Sorry. Why is that one wrong? Yep. Exactly. Okay, so this one's wrong, because does it work for the minus 10 though? Does that one give us the minus 10 we need? It does, but as Ataya said, if you expanded that, it gives me a minus 24, not a positive 24. There's not very many factoring questions where it looks like 2 answers are going to work, okay? But there is the odd one that you have to be careful. You do have to make sure, guys, you do your little checklist, do your expansion in your head, make sure all the signs line up, right? Because this one, right, is wrong. Okay, that one we can't do because, right, it does give me a minus 24. Okay, so that's a no-go. So this is the only correct answer. All right, so that is it. Okay, so please, there's one other type of factoring. We might get to it today that is kind of a one-off, but what we did last class and today, if you can do those 2 things well, okay, pre-calc is going to be a lot easier for you because there's factoring throughout 20-1, throughout 30-1, and throughout calculus, right? Factoring is kind of a key skill. So keep practicing it. So please make sure that your lesson 3 is all done. So all your factoring from yesterday is all done. And then make sure in your assignment book, go to your lesson 4 assignment, because they'll all be mixed together, right? So there's going to be some that have just GCF. There's going to be some that have no GCF and just your 2 brackets, and some will have both, just like we did in this lesson. So have fun factoring.